history of the Schwerer Gustav cannon began long before its first shot was fired. It was born not only out of the ambitions of the Third Reich, but also out of the restrictions imposed on Germany after World War I. The Treaty of Versailles significantly restricted the German armed forces. Large-caliber artillery, fortification systems, and heavy weapons were strictly controlled. But with Hitler's rise to power, these restrictions began to be gradually ignored. Germany embarked on a course of rearmament. In the mid-1930s, the German military leadership set a specific task for industry: to create a cannon capable of destroying the strongest fortifications in Europe. This primarily concerned the French Maginot Line, a system of concrete fortifications that was considered virtually impregnable. The task was ambitious. The shell had to penetrate up to 7 meters of reinforced concrete or 1 meter of steel at a great distance. Conventional artillery could not do this. Something unprecedented was needed. The project was entrusted to the Krupp company, which already had experience in creating heavy artillery. The engineers faced a problem of scale. To achieve the necessary penetrating power, the caliber of the gun had to exceed anything that had existed before. This is how the concept of the 800mm gun, the largest in the world, came about. It was to fire shells weighing over 7 tons. The barrel was over 30 meters long. It was then that it became clear that this weapon would not be mobile in the usual sense. The designers decided to place the gun on a special railway platform. It was to move only on rails, and special positions had to be prepared for its installation. The project ceased to be just a cannon. It became an engineering complex. Work began in 1937. Hitler was personally interested in the development. For him, it was not only a military, but also a symbolic issue. The giant cannon was supposed to demonstrate Germany's technical superiority. However, even at the initial stage, doubts arose. Some military personnel believed that such a weapon would be too difficult to use and too expensive. But political will prevailed over practical doubts. Thus began the history of the gun that became a symbol of the Third Reich's engineering gigantism. It was born as a response to fortifications, but eventually became a symbol of the very logic of total war, when scale and power seemed more important than mobility and flexibility. Years of development, testing, and preparation lay ahead. And although its creation seemed like a triumph of technology, real war would show whether these ambitions were justified. After the project was approved, Krupp faced an unprecedented engineering challenge. In theory, an 800mm gun could penetrate any concrete bunker known at the time. But in practice, it was not enough to simply design it. It had to be built. The first problem was the barrel itself. It was over 30 meters long and weighed hundreds of tons. The metal had to withstand enormous pressure during firing. Production required new steel processing technologies and enormous industrial capacity. Each shell was an engineering masterpiece. The weight of an armor-piercing shell reached about 7 tons. High explosive shells were even heavier. Their manufacture required precision, because even a slight error could lead to disaster during firing. The gun could not be ordinary field artillery. It required a special double-track railway platform. The entire structure weighed over 1,300 tons. Separate trains were used to transport it, and it took days to assemble it in position. The assembly process was complex and lengthy. First, the site was prepared. The ground was leveled, special rails were laid, and a fortified position was created. Only then did they begin to assemble the gun itself, which required hundreds of people and heavy equipment. The tests were conducted at a training ground in 1941. The first shot demonstrated technical prowess, but also revealed the scale of the problems. The recoil was enormous, and the barrel wore out quickly. After a limited number of shots, the barrel needed to be replaced. Despite this, the project was deemed a success. The gun was officially named Schwerer Gustav, in honor of Gustav Krupp. Later, another similar gun was created under the name Dora. But even at the testing stage, it became clear that this weapon was not universal. It was extremely powerful, but at the same time slow, vulnerable, and dependent on railway infrastructure. More than 1,000 people were needed to operate the gun, including security, technical personnel, and anti-aircraft units. It was not just an artillery system, it was an entire military complex. Engineers had created a giant capable of changing the course of a siege. But the war was already beginning to change. Maneuver warfare and aviation were gradually becoming more important than stationary siege systems. Combat use was ahead, and it was this that would show whether the heavy Gustav would really be a decisive argument on the battlefield, or just an expensive demonstration of force. By 1942, Germany had already advanced deep into the territory of the Soviet Union. One of the key targets in the south was Sevastopol, a well-fortified base of the Black Sea Fleet. The Soviet defense relied on powerful concrete fortifications, artillery batteries, and underground shelters. It was here that they decided to use the Schwerer Gustav. Transporting the gun to Crimea was a separate operation. It was delivered in parts by rail, under guard, and with careful route planning. Any damage to the rails or bridges could have ruined the entire plan. A special position was prepared near Sevastopol. Engineers leveled the site, laid double rails, and created a shelter. The installation of the gun took several days. Hundreds of soldiers, technicians, and guards were involved in its maintenance. The first shots were fired in June 1942. Shells weighing several tons flew into the air with a deafening roar. The explosions were so powerful that they could be felt at a great distance. According to eyewitness accounts, the ground shook. The gun was aimed at Soviet fortifications, in particular at fortified coastal batteries. Some objects suffered serious damage. The shells pierced thick concrete slabs and caused large-scale underground explosions. However, the effect was not as clear-cut as expected. Although some fortifications were destroyed, the defense of Sevastopol held thanks to the combined use of artillery, aviation, and infantry. Heavy Gustav was only part of a large offensive operation. During the siege, the gun fired less than 100 shots. The barrel wear was significant, and each shot required complex preparation. The rate of fire was low, a few shots per day. Despite this, the German command considered the use of the gun to be successful. Sevastopol fell in July 1942. Propaganda actively used the image of the giant gun as proof of the Reich's technical superiority. But the reality was more complex. The war on the Eastern Front was already turning into a large-scale confrontation, where maneuverability, resources, and endurance were decisive. The giant gun looked impressive, but it was not a universal solution. Sevastopol was the only significant combat use of the heavy Gustav. After that, the question arose. Did it make sense to maintain such a cumbersome system in the context of an increasingly mobile war? After the fall of Sevastopol, the question arose. What next? The Schwerer Gustav cannon was designed to destroy super-powerful fortifications, but the war was changing. Germany was no longer conducting large-scale sieges like in World War I. The fronts were moving quickly, and aviation was becoming the main striking force. There were plans to use the gun against Leningrad. However, logistical difficulties and the strategic situation prevented this from happening. Transporting the gun required time, prepared tracks, and complete security along the route. The conditions on the Eastern Front made this almost impossible. In 1943, the initiative finally passed to the Red Army. German troops began to retreat. Siege artillery lost its meaning in a war that was becoming increasingly mobile and chaotic. In addition, Allied aviation intensified its strikes on Germany's railway infrastructure. Large stationary systems became vulnerable targets. For Gustav to function, it needed not only a place to fire, but also a fully protected railway network. Maintaining the gun remained difficult. Thousands of people were involved in its support, from technical specialists to security guards. At a time when Germany was already experiencing a shortage of resources and manpower, maintaining such a giant became a luxury. There was a second gun, the Dora, which was almost identical in characteristics, but it too did not see significant combat use. Both systems gradually lost their strategic relevance. The German command increasingly relied on rocket programs such as the V-1 and V-2. They were cheaper to operate and more difficult to intercept. The era of super-heavy siege artillery was coming to an end. By 1944, the heavy Gustav had effectively become a symbol, a demonstration of engineering prowess, but with no real impact on the course of the war. Its enormous size became more of a burden than an advantage. As the Allies approached German territory, the question arose, what to do with the gun? Evacuation was difficult, and the risk of capture was undesirable. The giant, created to destroy fortresses, found itself trapped in a changed war. Its story became a story of ambition that did not correspond to the new reality. By 1945, the war had turned into a struggle for survival for Germany. The fronts were rapidly approaching its borders. Allied aircraft dominated the skies, and the railway infrastructure had been systematically destroyed. Under these conditions, the Schwerer Gustav had finally lost all strategic significance. The gun, designed as a tool for breaking through concrete fortifications, no longer suited the nature of the war. Battles were now fought quickly and maneuverably, rather than in long sieges. Moving such a giant became practically impossible due to destroyed tracks and constant airstrikes. The German command was aware of the risk of the gun being captured by the Allies. It was a unique piece of technology, and its capture by the enemy could have propaganda and technical implications. Therefore, the decision was made to destroy it. In the spring of 1945, as Allied troops advanced deep into Germany, Heavy Gustav was blown up by its own crew. The remains of the huge structure were found after the end of hostilities. Only twisted metal fragments remained of the giant gun. The irony was that a weapon designed to destroy the strongest fortresses was itself destroyed without a fight. It did not have a decisive impact on the course of the war, and did not become a strategic factor in the conflict. The project, which cost enormous resources and years of development, ended without a grand finale. It was not used in the key battles of the end of the war, and did not become the weapon of victory as its creators had hoped. After the war, the Allies studied the wreckage and analyzed the design, but quickly realized that the era of such artillery was over. Aviation, rockets, and mobile systems had permanently changed the nature of warfare. The Heavy Gustav became an example of how technical grandeur does not always equal strategic effectiveness. Its story is one of excessive reliance on scale. The gun was created as a symbol of the Reich's power, but its story ended as a symbol of collapse, abandoned, blown up, forgotten among the ruins. The giant emerged from the Empire's ambitions and disappeared along with it. After the war, historians and military analysts repeatedly asked the question, was the Schwerer Gustav an effective weapon? The answer turned out to be more complicated than a simple yes or no. From a technical point of view, the gun was a real engineering breakthrough. Its 800mm caliber, multi-ton shells, and ability to penetrate several meters of concrete were all unique. No other artillery system in the world had achieved such parameters. However, war is not only about technology, but also about the context in which it is used. The gun did indeed cause significant damage near Sevastopol, but its impact was local. The city fell not because of a single shot, but because of a complex operation involving massive artillery, aviation, and assault units. The rate of fire was low. Preparing for a single shot took a long time. Each shell required complex logistics. In the realities of mobile warfare, this became a serious disadvantage. In addition, barrel wear was high. After a limited number of shots, it had to be replaced. This required returning the gun to the factory or lengthy repairs, which further reduced its practical value. Another aspect was resources. The creation and maintenance of the gun required enormous amounts of steel, labor, and transport. At a time when Germany was already facing a shortage of fuel and materials, such projects seemed increasingly unjustified. Compared to aerial bombing or missile programs, the effectiveness of the Gustav seemed limited. Aviation could strike faster and at more points simultaneously. At the same time, the psychological effect was significant. Soviet troops near Sevastopol heard the rumble of giant shots. German propaganda actively used the image of the gun as a symbol of the Reich's technical superiority. But psychology is no substitute for strategy. In the end, the Heavy Gustav did not become a decisive factor in any major campaign. It remained an example of how military ambitions can outweigh practical considerations. From a historical perspective, the gun became more a symbol of engineering gigantism than an instrument of victory. Its history showed the limits of power when scale does not correspond to the realities of war. The story of the Schwerer Gustav was not unique in its pursuit of scale. It was part of a broader trend in the Third Reich, the creation of the so-called Wunderwaffe, or miracle weapon, which was supposed to change the course of the war with one decisive technological breakthrough. After 1942, when the strategic initiative began to slip from Germany's hands, the focus on innovation increased. The V-2 rockets appeared, becoming the first ballistic missiles in the world. Their technology was revolutionary, but their practical effect on the front lines was limited compared to the costs. Another attempt was the V-1 flying bomb. It was cheaper and was used extensively against London. But here too, the strategic result did not meet expectations. Heavy tanks such as the Tigerin appeared on the ground, surpassing many Allied vehicles in armor and firepower. However, the complexity of production and maintenance limited their numbers. All these projects were united by one idea: technological superiority can compensate for a lack of resources. The Heavy Gustav was the first major example of this logic. Its creation demonstrated the belief that one giant tool could solve the problem of fortifications. But war is a system. It requires flexibility, speed, and mass production. Superweapons often prove too complex, too expensive, and too slow. There was also a propaganda aspect. Giant guns, rockets, and tanks became symbols of the Reich's power. They created the impression of technological invincibility, even when the front was retreating. However, betting on individual innovations could not compensate for the Allies' industrial advantage. The US and the Soviet Union produced thousands of tanks, aircraft, and guns. The scale of production became decisive. In this context, the Heavy Gustav looked more like a harbinger of future technological races than an effective weapon of its time. It demonstrated that technical supremacy does not always mean strategic supremacy. The era of superweapons revealed the limitations of gigantism, and this was one of the lessons of World War II. Victory is determined not only by innovation, but also by the ability to integrate it into a broader system of warfare. The creation of the Schwerer Gustav was not only an engineering challenge, but also an economic one. At a time when Germany was preparing for a major war, every ton of steel, every hour of labor, and every railroad car was of strategic importance, and the Heavy Gustav consumed them on a massive scale. The production of the gun required hundreds of tons of high-quality steel. The Krupp factories were not only busy with this project, they were also producing tanks, artillery, and ammunition. In a total war, any large project meant a redistribution of resources. The economic logic of wartime demanded efficiency. However, the Gustav was an exception. Its production took years, and its combat use was limited. On the scale of the front lines, it looked like an investment with minimal strategic return. In addition to the production itself, it was necessary to maintain the infrastructure. Special railway tracks, transport trains, technical personnel, all this required constant funding and security. With Allied aircraft actively bombing German factories and transport hubs, supporting such a project was becoming increasingly difficult. Human resources were particularly noticeable. Hundreds, and in fact thousands, of people were involved in maintaining the gun. At a time when the front lines needed infantry and technical specialists, maintaining such a complex was becoming a luxury. In 1943 to 1944, when Germany was already experiencing a shortage of fuel, raw materials, and labor, such projects increasingly looked like a legacy of pre-war optimism. The war demanded mass production, not individual giants. Economic pressure intensified with each passing month. Allied bombing of industrial centers, including Essen, the heart of Krupp production, reduced productivity and complicated logistics. As a result, the Heavy Gustav became an example of the imbalance between technical ambition and economic reality. It demonstrated the capabilities of German engineering, but at the same time showed the limitations of the Reich's resource base. While such projects seemed justified at the beginning of the war, they became a burden in the second half. The war required consistency, not symbols. The giant gun cost Germany dearly, not only in steel and money, but also in lost opportunities to produce more practical weapons. After the war ended, the Schwerer Gustav ceased to be just an artillery system. It became a historical symbol, an example of how technical gigantism can turn into an illusion of strategic superiority. During the war, Nazi propaganda actively used the image of the gun. Photographs of the giant barrel, multi-ton shells, and hundreds of soldiers around it created an impression of invincibility. Schwerer Gustav was supposed to show the world that German engineering was capable of the impossible. For soldiers, it was a spectacle. The size of the gun impressed even those who saw it with their own eyes. It was so large that people next to it looked tiny. This created a sense of grandeur, but also a certain absurdity. After the war, historians began to rethink the significance of the gun. It became an example of the Third Reich's gigantomania, the belief that scale alone is proof of power. In military theory, it is often cited as an example of the imbalance between technical capabilities and strategic expediency. In popular culture, Heavy Gustav appears in documentaries, books, and even computer games. Its image remains as one of the most famous artillery systems in history. However, its actual combat role was limited. It did not determine the course of the war, nor was it a decisive factor. Its history is more about ambition than practical results. In a broader context, it became a symbol of how totalitarian regimes often rely on showy power. Large projects, grandiose constructions, and loud demonstrations were all meant to support the belief in the invincibility of the state. But the war proved otherwise. It was not individual giants that proved decisive, but consistency, mobility, and resource base. Mass production of tanks, aircraft, and artillery proved more effective than the creation of extremely complex individual weapons. The Heavy Gustav went down in history as a technical marvel of its time. But at the same time, it served as a reminder of the limits of power. Its fragments have disappeared, but its story has been preserved as an example of how technological excellence does not guarantee strategic success. The story of Schwerer Gustav is more than just the story of a single gun. It is a story of ambition, engineering audacity, and strategic mistakes. It began with the desire to overcome fortifications, but ended as a symbol of the limitations of power. Germany created the largest cannon in human history. It proved that almost anything is technically possible, even an 800mm barrel capable of firing 7-ton shells. But the war showed that possible does not always mean practical. The Heavy Gustav was a product of pre-war thinking, when war was still imagined as a series of large sieges and breakthroughs of fortified lines. However, the real Second World War quickly became a war of maneuver, logistics, and mass production. The gun became an example of how scale can become a limitation. Its mobility was minimal, maintenance was difficult, and its use was rare. It required enormous resources at a time when Germany was already experiencing a shortage of them. At the same time, its creation was not futile from a technical point of view. The experience gained in steel processing, heavy construction logistics, and the organization of large-scale engineering projects became part of industrial history. But the cannon had no strategic impact on the war. Its fate reflects that of the Third Reich itself. Grandiose ambitions, a demonstration of power, and ultimately collapse under the pressure of a more systematic enemy. The lesson of Heavy Gustav is that war is not just about striking power. It is about the balance between resources, mobility, technology, and strategy. Over-reliance on one element may create the impression of superiority, but it does not guarantee victory. Today, this cannon is remembered as an engineering record and a historical phenomenon. It became part of military legend, but not part of the decisive turning point of the war. The giant, which was supposed to destroy fortresses, itself became a monument to the limitations of excessive force. And this is its main historical lesson.